All right, here we go. We're going to talk about the geometric mean of two numbers, and then we're going to do that idea with the three triangles, the small, medium, and large, and we'll be able to figure it out from this second problem. But the first one is pretty simple. We just want to find the geometric mean between 6 and 15. That means we're going to take the square root of the product of the two numbers. It's as simple as that. And so we're going to take 6 times 15, which is 90. So the square root of 90. Now, if you want to put this in simplest radical form, I simply recommend that we break down 90 into factors of 9 and 10. It doesn't matter what factors you choose. I'm choosing 9 and 10, 3, 3, 2, and 5. And those are the factors. So this can be thought of as the square root of 3 times 2 times 5. 3 times 3 are perfect squares because it's a pair of numbers. That comes out of the radical. So in the end, we have to multiply those two back together. We get 3 radical 10 is the same thing as saying radical 90. So we've got radical 90 for a solution, or 3 radical 10. All right, second question. What are the values of x and y? So you've got a right triangle. We've drawn that altitude. So we're going to draw 3 similar triangles, a small, a medium, and a large. This is the best way to do it, not dealing with those ratio or with those corollaries and the theorem. That's really a bad looking triangle, but we're going to call it a right triangle. So the small one is right here. So we got to put the numbers in the right location. So the 4 is the smallest length, that's there. The hypotenuse is x, and the short leg, or the longer leg, is y. So I put those numbers there. In the medium triangle over here, I've got the long leg is 12, the bottom short leg is y, and there is no hypotenuse, leave it blank. In the overall triangle, I've got the bottom part is x, the hypotenuse is actually 16, 12 plus 4, and there's nothing there, so leave it alone. So we've put the information we need in here. Now it's a matter of using these triangles, trying to figure out what proportions to set up equal to each other, because these are similar triangles. So let's look at x. So I look at x and I see that x over 4 and x over 16, they're corresponding pieces that involve x. So I'm going to write x over 4 equals 16 over x. And if I solve that, I'll get x. So I'm going to get x times x, that's x squared. 4 times 16, not sure. 4 times 16 is 64. And so I can take the square root of 64. X will be 8. So that's a lot easier than thinking about those theorems. For y, we'll do the same thing. So these two triangles have y in them. It looks like y goes with 12, and 4 will go with y. So y over 12 equals 4 over y. And so we do the cross products. That's y squared. That's 12 times 4 happens to be 48. We take the square root of both sides. 48 is not a perfect square, so let's write it in simplest radical form. Pick any two factors of 48. I don't know, 4 and 12 maybe. Let's break this one down to 2 and 2. Let's break that one down to 4 and 3. And these don't break down, but 4 breaks down to 2 and 2. So this would be the square root of 2 times 2 times 2 times 2 times 3. This is a perfect square. It's a pair. It comes out of the radical. This is another pair of 2's. It comes out of the radical. So if you take 2 2's out of the radical, you got to multiply them together in the end. You're going to get 4. That radical 3 stays put. 4 radical 3 is our value for y. 8 was our value for x. That's how you do those types of problems. Don't try to think of the theorems and the corollaries. Instead, create a small, medium, and large triangle. Put the pieces of information where they belong, and then try to solve them that way. To me, that's a whole lot easier.